This is Dr. C. Sonia, Assistant Professor in Chemistry, SNS College of Technology. So, what is electrochemistry? Its branch, it is the interconversion of the chemical and the electrical energy through redox reaction. So, the concept here is the redox reaction, which is the heart of electrochemistry. Electrochemical cell. It's a device where electrochemical reaction occurs. The chemical energy is converted into electrical energy and vice versa. So examples are the galvanic cell or the voltaic cell, electrolytic cell. Now we are welcoming into the fascinating world of electrochemical cells. So we'll explore the chemistry behind converting the chemical energy into electrical energy and vice versa. These cells are essential in our daily lives, powering the countless devices and protecting vital infrastructure. So this is a DD-based video. We are first going to empathize, that is, where do we see the chemical reaction involving electricity? So the example, it's in the batteries. The batteries rest. Phone batteries where the corrosion occurs. And also we see the corrosions on the bike metal frames and any other metal frames. So it is now important to define the problem. How can we harness the electron transfer for the practical use? So electrochemistry is the study of chemical process involving the electron transfer. So defining that, an electrochemical cell is a device that either converts chemical energy into electrical energy, so thus they generate the electricity, or uses the electrical energy to drive non-spontaneous chemical reactions. It involves the redox reactions, as I said, and the key components include the anode, where the oxidation occurs, that is the loss of electrons, cathode, where the reduction occurs, it's the gain of electrons. Electrolyte, it's a solution containing ions that allow charge flow. What's a salt bridge? It connects to two half cells, maintaining the charge neutrality by allowing the ion flow. So the electron flows through the external circuit from the anode to the cathode, while the ions flow through the salt bridge to complete the circuit. So this we have to prevent the corrosions in the pipelines. So there are different types of electrochemical cells. So the ideate part is example electroplating. So how can the electrochemistry solve energy or material problems? So battery powered electrical vehicles. By using this battery powered electrical vehicles, by using the electroplating techniques, you can control the corrosion. That is, electrochemical cells are broadly categorized into two main types, depending on whether the redox reaction is spontaneous or requires external energy. So here, to get into this idea, you have to define what are the different types of electrochemical cells. That is the galvanic cells and the electrolytic cell, which I mentioned earlier. These cells generate electricity through spontaneous redox reactions. They convert the chemical energy into electrical energy. So a common example is the batteries, which we rely on a daily for power. A very simple example is the usage of smartphone by us. So smartphone, it discharges after charging. When you use it, it discharges the and you use them by discharging the current. Electrolytic cell, in contrast to the electrolytic cells, use an external power to source to drive the non-spontaneous redox reaction. They convert the electrical energy into chemical energy used in process like electroplating. So here, even here, we can take a Our phones as an example where you charge the phone to use it after discharging. So powering everyday devices, batteries are quite essential examples of galvanic cells transforming the stored chemical energy into electrical energy to power our world. There are two main types of batteries. So here, the prototype and testing, a battery circuit. You can construct a simple toy battery. So there are two types of batteries, that is the primary battery. This is non-rechargeable, designed for single use. Example include the common alkaline battery found in TV remotes or flashlights. Secondary batteries, rechargeable, capable of multiple charge and discharge cycles. That is, example is the lithium-ion battery in smartphones and laptops are the prime examples. The principle is simple. The chemical reactions within the battery cause electrons to flow from the anode to the cathode through an external circuit, producing electric current. So, the electroplating technique, that is the idea, that is the electroplating is a crucial industrial applications of the electrolytic cell where a thin layer of the metal is deposited on the surface of another object. This process involves submerging the object to be plated, that is as a cathode, and the plating metal as the anode into the electrolyte solution. An external power source drives the reduction of the metal ions from the solution onto the object's surface. Electroplating serves multiple purposes. One is the corrosion resistance, protecting underlying metals from the rust and degradation. Example chrome plating. Then wear protection, enhancing the durability and the hardness. Aesthetic appeal, providing the decorative finish such as gold or silver plated jewelry. It's also used in industry from automotive to electronics. Fuel cells, they're the clean energy conversions. Here comes the applications. The fuel cells are electrochemical devices that convert the chemical energy of the fuel, like hydrogen, and oxidate, like oxygen, directly into the electricity, heat, and water. Unlike batteries, which store energy, fuel cells produce electricity as long as the fuel and the oxidant are supplied. They are highly efficient and produce significantly lower emission compared to the traditional combustion engines. So the applications of these are found in the zero emission vehicles, example hydrogen cars, backup power system of critical infrastructure and even spacecraft. There are different types of hydrogen fuels, and the potential for the clean and sustainable energy production makes them a key technology for the future.